Hi, ladies and gentlemen. So in Unit 3, we are starting to learn all about polynomials. So Lesson 3.1 is an introduction to polynomial functions. So starting off, here's a warm-up. It says evaluate, so a little bit of exponent rule reminders, and then working on simplifying the expressions in parts A and B here. So take a moment to work on those and then press play to see the answer. So looking at the first one, number 1, part A, and I'm going to move my face a little bit. Here we go. So looking at number 1, part A, it says -2 to the power of 4. What we want to be mindful here is that there's no parentheses. So what this problem is telling us to do is to take negative and then multiply 2 by itself 4 times. Okay, and that's going to end up giving us a -16. So we have to basically compute this 2 to the power of 4 first, then multiply it by the negative. When you look at part B, that one is written differently. Part B has parentheses around -2, which means we're going to be taking -2 times itself 4 times. Like so. And that's going to give us a +16 because the negative number times itself 4 times is going to be positive. All right, taking a look at parts A and B underneath with simplifying each expression. So for the first one, it wants us to simplify the expression x minus 2 times the quantity 3x minus 1. So for the very first part of this, we had to look at what is outside our grouping symbol. So you could look at this as a +2, but that 2 is negative technically. So when you're approaching a problem like this, pull that sign with the number, and we're going to take this -2 now and distribute that into our grouping symbol. So let's do it all at once versus distributing the 2 first and then the negative second. Doing it in one step as a -2 will be best. So that will give us x. -2 times 3x is -6x. -2 times -1 is +2. So what I did here, just to color code things a little bit so it's easier to read, I took -2 times 3x and I got -6x. And then I took -2 times -1 and I got +2. Combining like terms from here, I have the two x terms I can combine. So I have x minus 6x, which is -5x, and then the +2 carries down. Looking at the second one, distributing the 3 into the parentheses will give us 3y squared plus 18y. There's nothing to combine here because y squared and y are not like terms, so this one is as simplified as it can get. Our objectives for today are to identify, evaluate, add, and subtract polynomials, and then classify and graph polynomials. In order to identify what a polynomial is, we first need to have an understanding of what a monomial is. A monomial is a number or product of numbers and variables with whole numbered exponents. The degree of your monomial is the sum of the exponents. We're going to go through an example of this to give you more experience with what a monomial actually is. So here are 4 examples of monomials in example 1, and we want to identify the degree of each. To identify the degree of your monomial, you're looking at the sum of your variable exponents. So in part A, z has an exponent of 6, and it's the only variable and it's the only exponent. So our degree here is 6. If we look at part B, we just have a number. We have a number 5.6. There's no variable here. So when you have just a number or just a constant, its degree is 0. Looking at part C, we have 8xy cubed. We have 2 variables here. We have the x variable, and then we have the y variable. We want to take each of their degrees and add them together. Well, x has a degree of 1, and y has a degree of 3. So the degree of the entire monomial, 8xy cubed, would be 4. And last, looking at part D, we have a squared bc cubed. Adding our degrees, that b in the middle technically has an exponent of 1. So taking 2 plus 1 plus 3 is going to give us the degree of the entire monomial, which is 6. So a monomial is just a single term. The way you identify its degree is looking at your variable's exponents, and if you have multiple variables, adding those exponents together. Now let's define what a polynomial is. A polynomial are the sums and differences of monomials. Just like when we were dealing with quadratic functions, we had 3 pieces or 3 terms added together. Well, each of those terms was a monomial, and technically a quadratic function is a polynomial. So how do we identify the degree of a polynomial? Well, the degree of a polynomial is identified by looking at the monomial with the highest exponent, or the largest degree. More often than not, we deal with polynomials with just one single variable, so we often approach it as what is your highest exponent, and that becomes the degree of your polynomial. We really have to look at largest degree when we're dealing with polynomials that have multiple variables, but we really won't be dealing with that very much in this chapter. Standard form of a polynomial is where the exponents go in descending order. Leading coefficient is your number or your constant or your coefficient in front of the term with the highest degree. So an example of standard form leading coefficient and degree of a polynomial is what we have in the bottom right corner of this slide. You can see that we have this equation 5x cubed plus 8x squared plus 3x minus 17. Our leading coefficient is that number in front of your variables with the highest degree. In this case, our highest degree is 3. If you look at the degree of each of the individual terms, notice that they go in order. 5x cubed has a degree of 3, 8x squared has a degree of 2, 3x has a degree of 1, and the number negative 17 has a degree of 0. And those degrees go from highest to smallest. Let's look at some examples of what are polynomials and are not polynomials, because that sometimes can be helpful when determining between the two. So things that are polynomials are like 3x to the 4th, 0.15x to the power of 101, 1/2 times a to the power of 7. Things that are not polynomials, 3 to the power of x, where x is the exponent, is not a polynomial. M to the power of 0.75, so where we don't have these whole number exponents. Something here where we have these absolute value bars, not a polynomial. And when your variable ends up in the denominator of a fraction, also not a polynomial. So some examples of polynomials. In number 1, we have 8x to the power of 4 plus 3x squared minus 4. Well, first let's identify what the degree is and then use that to identify the leading coefficient. I have exponents of 4 and 2. Well, 4 is larger than 2, so that means my degree is 4. The number in front of that variable is an 8, so that's our leading coefficient. If we look at number 2, 6 is my highest exponent, so that gives me my degree. And the constant, or the number in front of that variable, x to the power of 6, is 10, so 10 is my leading coefficient. Notice that each of these two examples, they were written in standard form with the highest degree first and the lowest degree last. If you have a problem where it's not written in standard form, I would say the first step is to put it in standard form. Then you can easily identify your degree and your leading coefficient.